introduced a new mud removal package, the Well Clean service, to optimize the removal of the drilling mud from a well under a variety of conditions. Dowell Schlumberger has also developed a new family of spacers, the mud push spacers, two of which are designed to work in turbulent and one in laminar flow conditions. We're going to see a demonstration of the field mixing procedure for the turbulent flow mud push XT spacer prepared with seawater, and we'll demonstrate its superior weighting agent suspending properties. We'll also compare rheology of the field mixed spacer to that prepared in the laboratory. In the lab, the standard mixing procedure is straightforward. The objective of this preparation method is to produce a spacer sample which has the same properties as those obtained under field mixing conditions. This method simulates as closely as possible the high shear produced for short periods of time by a jet mixer and centrifugal pumps, and the low shear obtained for relatively long periods of time with the agitator. As a result, the laboratory mixing procedure incorporates both a wearing blender, high shear for a short time, and a propeller mixer, low shear for a longer time. We'll prepare 600 mils of spacer with a density of 14 pounds per gallon. This requires 9.8 grams of D147 gelling agent and 434 grams of barite. First, we add 1 ml of anti-foam agent to 466 ml of seawater. D144 is best. The D147 is mixed in the wearing blender at 4000 RPM for 5 minutes. This ensures proper dispersion of the powder. The fluid is transferred to a beaker, and the agitation is started using a propeller mixer for 30 minutes to allow for the hydration of the polymer. Be sure that a vortex is created. After this stage, it's important to check if the spacer concentrate is sufficiently hydrated. For this, the Marsh funnel with standard insert can be used. A Marsh funnel time of at least 42 seconds will ensure good weighting agent suspending properties. Checking the viscosity of the base fluid is particularly important if a spacer of low density is being prepared. A low density spacer is more prone to particle sedimentation than a high density spacer. Add the required amount of weighting agent slowly in the vortex and mix for an additional 10 minutes. We now check the rheology of the spacer using a standard viscometer. The 100 RPM reading shows a value of 9. We'll later check how the spacer mixed using field equipment compares to that from the lab by comparing the 100 RPM readings. Now the spacer will be mixed using field equipment. The equipment used here is a 25-barrel RMX recirculating mixer equipped with a slurry chief bowl. A variety of field equipment can be used, such as batch tanks, tornado mixer and jet mixers. Whatever the density of the turbulent mud push XT spacer, the concentration of D147 is the same. To prepare 20 barrels of spacer, less than 4 sacks of D147 are necessary. To prepare the spacer, only normal safety precautions are required. Boots, coveralls, gloves, safety glasses and hard hats are used. While adding the barite, dust masks should be worn. We'll prepare 20 barrels of Mud Push XT at 14 pounds per gallon. This requires 121 pounds of D147 and 4,900 pounds of barite. Now that the material is ready, let's start to prepare the spacer. First, add the anti-foam agent D144 at a concentration of 0.1 to 0.2 gallons per barrel of mix water. This is typically a large cupful. Cut the sacks of D147 into the hopper. The spacer concentrate is then mixed and recirculated until all the products have been dissolved, which takes 30 minutes if seawater is used. With fresh water, this is a little faster. A detailed quality control procedure is carried out on all the polymer batches by our technical centre in Holland before the product is shipped to locations. Note that virtually no foaming is observed. For offshore operations, when mixing in the slug pit, the mud hopper can be used provided that lines and equipment have been thoroughly cleaned and are free from mud residues. A sample of the spacer concentrate is taken and the viscosity checked using the Marsh funnel test. Remember that a similar test was run in the laboratory and gave 42 seconds. As you can see, laboratory and field results are in very good agreement. Now that we're sure that the spacer has developed the suspending properties required, the barite can be added up to the design density. It's recommended that the weighting agent be added directly into a point of significant agitation, i.e. into the hopper of a mixer or the vortex of the paddle tank, as in this example. After all the barite has been added, the mixture is agitated vigorously. After around 10 minutes, a sample is taken. Note how thin the spacer is. The density is checked using a pressurized mud balance. The design density was 14 ppg. For this demonstration, once the density was checked, a sample was taken for rheological measurement in the laboratory. Once again, as for the Marsh funnel test, excellent agreement is found between the laboratory sample and the spacer mixed in the yard. The critical rate for turbulent flow can now be calculated. In an 8.5-inch open hole for 7-inch casing that is well centralized, the critical rate will be just over 6 barrels per minute. The real test of a spacer's performance on a rig is how well it suspends the weighting agent in the surface equipment. For this test, we'll now turn the paddle and the centrifugal in the batch mixer off and leave the spacer sitting stationary for 4 hours. After this time, a sample is taken at medium depth to check the density. Note from the sample that the spacer has not developed any free water or gelation. The viscosity is still very low. If some sedimentation had occurred, the measured density would be different than the design density, as the weighting agent would have settled down in the tank. 14 ppg is obtained, demonstrating the excellent suspending properties of the spacer. After this, a further test was done, keeping the spacer under static conditions for another 20 hours. This is not normally recommended field practice, but it's done here to demonstrate the superior suspending properties of mud push spacer. As a quick check to see if sedimentation has occurred, the bottom of the tank is scraped with a metal bar. As can be seen, no barite has sedimented during these 24 hours without any paddling or recirculating. Then a sample was taken first from the top of the tank in order to measure the density near the surface. This showed 13.6 pounds per gallon. A second sample was taken from the very bottom of the tank via a discharge valve, and the density was found to be 14.4 pounds per gallon. These two readings mean that there is a small gradient of density in the tank after 24 hours under static conditions. However, in spite of this density gradient, no barite has settled out. It all remains suspended. As can be seen, the bottom of the tank is free of sedimented barite, showing the outstanding suspending properties of the new spacer. During the program, we have seen the suspending properties of the new turbulent spacer and how easy it is to mix it. Mud Push XT is for turbulent flow for mixing with fresh water, seawater, or up to 10% salt. For higher salt concentration, up to 30%, Mud Push XS is used for turbulent flow. And for laminar flow, the new Mud Push XL covers all types of mixed water, from fresh water up to 30% salt concentration.